Hello again. In this video I want to share some ideas on how we can understand, select and use models to define the requirements for a system that we trust, and also how to use those models to test as well. Now, models are everywhere, as I showed in the previous video, so we need to understand what models do for us and how to make informed choices when we make our models. To introduce the ideas here, I'll talk about models and perspective and viewpoints. From the perspective of testing, we tend to have to use multiple models because no model will find all the bugs, for example. No model will give us everything, all the detail we need from a test. So we have to use diverse models. Now, each model is imperfect, so we call them half measures. So there's a phrase, diverse half measures, that's common in testing circles. So I'll introduce that idea. Now, models simplify and reduce the scope from something that might be infinite to something more manageable. This is part of what models are about. So in that respect, we need to be careful about how we choose our models so we don't simplify too much. So how we select our models, there's some conversation on that as well. And then I'll summarize and close the video. So what models do for us is they simplify complex situations. Now, when we use a model to simplify, say, the appearance or the usage patterns of a complex system, we obviously exclude certain details which may or may not be important. So when we model, we scope. That's the way it works. Now, when our models are created, we know that our knowledge is never perfect or complete. So when we learn over time, by having a model in place, we can use that model to place the new knowledge and put it into context, if you like, to assimilate the new knowledge into our understanding. Now, as I said, models define a scope, so we can be very clear about what is in the model, as in scope, and what is not. So this helps us explain what we're trying to achieve with our modeling activity, with our testing, if you like. Quite often we model with some goal in mind. It might be to define a requirement or to articulate a design or to scope the testing we're going to perform on a user interface, perhaps. Another goal would be certainly to share understanding, and this is the most common in some respects. We have a common view of the complexity of a system through models to allow us to focus on some aspect or another, but certainly to share our understanding and have meaningful conversations about it. Now, models always use a perspective or viewpoint, and this perspective or viewpoint should match our purpose. So if we are doing user testing, our viewpoint naturally would be from a user or business point of view. Clearly, if I'm a developer, I take a much more code-centric perspective. So different perspectives implement different models because the users, the viewpoints differ in our businesses and our projects. I mentioned earlier in the previous video the saying by George Box, all models are wrong, some are useful. If our model is not useful, it's both wrong and useless. So we have this compromise, if you like. All models are a compromise. So we have to be careful how we choose ones that are most useful. So here's an example of a model. It's actually a house plan from 1926, of all things. The goal clearly was to plan a new house. The scope of the plan, as you can see, it just describes the structure. It doesn't mention furnishings or wallpaper or anything like that, or furniture. It's just the structure, internal and external, of the building, seen from different perspectives. From above as a plan, and you can see there's a ground floor and a first floor plan, and from the side, or elevations, if you like. So there's a front elevation and there's a section somewhere in the midway point of the house. Now, this plan, it deliberately excludes the services, gas and water pipes, the drains, the electrical stuff. And as I say, it doesn't mention furnishing or the furniture or decoration. Now, was this plan useful? Was this model useful? Well, I think so, because it's a plan of my house, long before my time. So I guess the model was actually useful in the first instance. Now, in order to specify or design or test a system feature, we might have one model, but more often we use different models. So the specification might be in the form of a user story and examples. The design might be a diagram or a flow chart that a developer sketches on a piece of paper before they write the code. And the tester might make a table of modes of failure and use that as a checklist to test that same feature. So these are all different models, and this is absolutely common across all activities in our projects. Now, just like the house plan, these models can represent different perspectives, whether it's the process from the perspective of the user or the business. Is it the user interface? So it's from the perspective of the user interacting with the system. Is it functional? So it's focused on the outcomes of the process, the code itself, running on a server perhaps? Or is the perspective from an architectural point of view? So, what are the components and how do these components interface and interact and collaborate? So all these different perspectives would generate, if you were using these perspectives, they would generate different styles of model. And typically, from the perspective of the whole system, we need to understand the system from several or perhaps many perspectives to build a useful feature, architecture, the system as a whole. Now, from a tester's perspective, all these models have some value. They focus on different aspects of the system, and from the tester's kind of point of view, they would draw attention to different risks of failure, whether it's a failure in the process of a system, the user interface, the functionality, or the architecture. Now, the difference in perspectives can expose misunderstandings. So when you take a developer view and a user view, quite often there's conflict between the two perspectives. So, here are some kind of cartoons, and I don't want to dwell on it too long, but it's very common for us to take different views of the same model or to have different models in our minds from other people. And when we discuss what we see through our model, through our perspective, it's very apparent how conflicts arise. And this is how misunderstandings can be flagged up. So the value of having models is partly to have a meaningful conversation to generate these misunderstandings and schisms in our projects. Now, it's well known that in testing there's no single test design technique, there's no silver bullet, there's no single model that would help you to find all bugs in software. It's well known. So when we model a system or situation, each model is good at highlighting different aspects, and it might highlight the user interface and the navigation path through the user interface, but that same model would say nothing about the back-end processing. So every model leaves gaps. Every model is a half measure, if you like. So we need to choose a range of models that cover the gaps across each other. So we choose models to fill the gaps of concern until we're satisfied. So our test strategy uses diverse, different models to test different aspects of concern. Now, this idea of diverse half measures, as it's called, should already be familiar. So when we test a system, we test it at a unit, integration, system, and maybe an acceptance level. These different test stages or levels take different perspectives and generate different models. Again, the non-functional tests, again, use different perspectives and different models. So performance, usability, security, each of these activities take a different model. Now, it could be in a complete system that you could model the complete system in one model. When we build and test a complete system, to create a model of the entirety of a system would be certainly too cumbersome and complicated and very difficult to manage and understand, I should think. So if you imagine drawing a flowchart of a large application with 1 million lines of code, it would look just horrendous. It would be so huge you'd never get your head around it. No one person could understand this thing. So we break these tasks down, these models from an architectural point of view. We might model an overall architecture, and then the components in that architecture are then modelled individually. And then there might be models of the relationships between the components in that architecture. So we do a divide and conquer approach. We break our large complex models into smaller, simpler models in order to understand the complexity. So how do we choose which model to use and when? And this clearly is the most important question of all. So let's explore that idea. Well, firstly, we model to simplify or scope our testing problem. So your system as a whole could be something as simple as an electric toothbrush, or it could be an airport, a huge enterprise. The system could be a single method in a small piece of software or a class, or it could be the entire business process. So there's a whole notion of levels of or a hierarchy of systems and system components. So different subsystems could be part of some architectural hierarchy, clearly, but we might also be dealing with something the size of an airport or a battleship or a hospital. And typically systems of this scale are not just one system, they are a system of systems. They're incredibly complex. I've said before that a complex system is often a system of systems. The system itself is so huge, it is broken down into many other systems. So what we can say about most organizations, and here would be an example, that they have groups of applications or systems that have kind of meaning in their clustering, if you like. So a typical grouping in an organization might be the website applications, there's the CRM, back-end systems, accounting, ERP, maybe there's a mobile app involved as well. This collection, this whole grouping of systems might be broken up into clusters in the way I've suggested here, based on either the technology or the purpose of those systems and the grouping. Some might be packages, some might be bespoke systems written by your own IT people. So when we look at something as complex as a system of systems, we can use our modelling to scope and to reduce the complexity and to take a subset, if you like. So what scoping is to take a large system and to take a subset, a perspective, a slice, a cut, a group, a cluster, any of these words. We use scope as a perspective almost, to take a specific view. So one example of this might be we take these three systems inside the red boundary because they share common functionality. They make use of a certain set of web services, perhaps, that we want to focus on. The path between the four systems indicated by the red dotted line might be a customer journey from visiting a website, using a product, making calls to a support services, to making payments and so on. So this journey might be the perspective. So the subset of systems we worry about would be those that are on the journey. Now another perspective might be, let's take the systems of record, the back-end systems that hold data for shorter or long periods or for all time. So the systems of record and the databases behind them, this is perhaps the scope, and this is perhaps our perspective. Now when we select a cluster or group of systems, we select the items in scope, but we deselect or ignore other items. The systems, the pieces, the components, the viewpoint of what is in scope tells us what we're looking at. It informs our testing where we're looking at something specifically in scope to achieve some goal. Now we can descope things in two ways, by omission. We just leave them off our model, but it could be that we descope by simplification. By simplifying our model, we ignore certain aspects that could be included, and we ignore things that perhaps for our current purpose are irrelevant. Now this might be a safe or it might be an unsafe assumption, so this is where we need to take quite a lot of care. We can choose models to simplify and de-scope things, but by excluding some aspects in our model, does the model become invalid? That is, are the things that we're ignoring not insignificant? That is, perhaps the things that we're ignoring in our model might affect the behavior of our system through the eyes of our model. So we have to be very careful not to exclude things that are seriously important. And there's an old saying attributed to Einstein, of course, which is everything should be made as simple as possible, but no simpler. What that is implying is that when we choose our models, the things we ignore, we have to be very careful about to ensure that they are not significant. So how do we choose our models? Well, one is to scope the problem, if you like, but use that scope to align with one of our goals. So the scope might be on the user interface, or the control flow of code, or the data and the combinations of data that we're concerned with. Our goals might be to focus on problems with the UI, or the flow of control in code, or in the data that's being processed. We identify testable functionality by scoping it in, if you like. When we select a feature, we are, if you like, scoping the model as saying this is the feature we're paying attention to, and we're excluding all other features. We scope to make things testable. Okay, that is very often our goal in that scoping is about selecting a testable component or subsystem, or maybe the entire system, a slice through it. Now, the risk of failure, or the patterns or modes of failure, can also shape our choices. So we might pay most attention to input validation on a user's screen, or navigation, or decision making. If we have concerns over where errors may occur because we have experience of them in the past, this can drive our modeling activity. Now, coverage is a measure of the comprehensiveness of our model, or when we use a model to test, of our testing. So coverage is critical to our understanding of how our model articulates the amount of testing we do in that respect. So we can identify measures of completeness by counting things in our model. So for example, if our model is a flowchart, we can count processes on the model, all processes coverage perhaps. We can count the outcomes of decisions. We can count decisions on their own. And each one is a measurable way of defining a comprehensiveness of our model, but also of our testing. So the coverage is critical to our understanding of what a model does for us. So if we can count paths or edges or combinations of nodes in our model, we can measure coverage in a more systematic way. Now, overall, there are no fixed rules for choosing our models. All systems differ, every stakeholder group is different, they want different things, and every project, of course, is unique. There are no hard and fast rules for choosing our models. But it's clear that the dimensions that I've tried to talk about in terms of scope and inclusivity of coverage, these are the things that determine how we choose our model. Now, overall, we have to place a lot of reliance on experience, and modelling and practicing modelling will help you a lot. And certainly examples that I'll show you in the videos that are to come will help you, I hope, to understand how modelling shapes how we make our decisions in test design.